Okay, so for this video, I'm going to do a LPM counter. However, rather than use the mega function on the block diagram, I'm going to do it in VHDL. As normal, I have a basic file set up with this. I'm going to be using a clock divider to clock through on this counter. And I've already got that in here. And then the basic shell of the VHDL that I'm going to use. As you can see, there's an instruction manual that explains the different features of the LPM counter. And it tells you, what the name is, the type of it is, the input, and it gives you a description. You have both ports, and then on the second page, you have parameters. You'll notice that the only thing that is required is the LPM width. Everything else is optional. Though, for our purposes, some of these things are not going to be optional because we want to do this. So for this example, I'm going to make an 8-bit counter. I want it to have an asynchronous clear. I want to have a synchronous load. I want it to have a count enable, and I want it to have a clock enable. And this will count up. So the first thing that needs to happen is we need to write the VHDL so that it actually knows that we're using LPM. So to do that, we come up here to Library. And we put in LPM. And we're going to have to use it. And that tells the program that we're going to be using the LPM library, and we're going to be using all the components from the components from the sub part. All right, so for ports, this I can use whatever I want to do. I'm just going to use regular names, so I know that I want a clock. I'll use regular clock. We want to clear, load. I want a clock enable, and I want a count enable. And these are all standard logic input bits. Now, because I'm going to be loading, I do need to have a load. And for this, it's in. So LPM's going to be in a standard logic vector. And this is 8-bit, so it's 7 down to 0. And what must go in must come out. So just sit there and just flip it over. And that is everything on the outside. So to begin. Now this is going to work a little different. You don't have to actually specify out what's going on the inside because the LPM counter by itself already has all that. You're just basically defining what the actual ports are. So for this, we're going to do what's called a generic mount. Well, first we need to actually call it. So in the begin, and it's LPM counter. And then it's going to be a generic map. And you can see that these are keywords. These are the parameters that I'm going to be using. As you remember, the LPM width has to be defined. So and we're going to define it as, whoops, 8. Now, need to set the port map. So these come with port maps. So very similar to port up in the entity, just slightly different naming convention. Because basically what we're going to be doing is we're going to be taking these ports that are here and defining it to the actual ports that we're making our device. So just go ahead and clock, and then clear, load, clock, enable, count enable, and then we got a PN and Q out. And that's the end of that. Oh, need to make sure we put the semicolon at the end of that. This works very same as the port, works just the same as the port up in the entity. Oh, probably going to need to put in. Okay, we're good here. All right, so clock goes to clock. Actually, interesting. So a clear. So if you look over here, asynchronous clear, default to 0. And we're going to assign that to clear. If I can actually type right tonight. And the load was synchronous. So as there is no actual load, there is a load, synchronous load. S load. And then clock enable. Let's see. That's count enable. That's going to be useful. Let's put that in right now. And clock enable. Clock enable right there. So PN is, as you'll see, data input. So data. Now for this, we need to actually define the array that it is. We don't need to do the standard logic vector because we've already defined it as a 8-bit binary array. And then this is my out. So we look down through the ports and you'll see we have an EQ out and we have a Q out. The little symbol there means it's an array. Let's see, counter decode output active high when the counter reaches specified value. Data output from the counter. We'll use that one. And it too is a. All right. And we'll compile this. don't think this is going to work. Or it is. All right. So that compiled. Now the question is this actually going to work how we want it to do? So I'm going to go ahead and set it as my top. And compile. All right, now we're going to do vector waveform file. All right, so I know my clock. I want this to be clocking through. Let's see, I really don't care about my load, but let's go ahead and set it up anyways. An arbitrary value, let's say AA. Oh, that's right, it doesn't like AA. So let's say 135. Don't need to set output. So clock enable. So if we look here at the manual, this is the thing that you have to pay attention to is what are you actually sending in? So with the push buttons, if I push the button, it grounds it out. So I need to have highs to be not active. So that's going to be a high. Let's see, clock enable, count enable. Load is going to be a high. Now let's see, clock enable and count enable. If we look at the data sheet, count enable input disables count when low. So we want clock enable to be high. Clock enables all synchronous activities, default is 1, so that needs to be high. And so if we run a functional on this, it does nothing. Okay. So what does it actually need? So let's move my clock to the top. I'll put clear down here. Go ahead and we'll just set clear to low. Well, that's interesting. Set that to low. Well, what do you look at that? So I'm going to go ahead and change the binary, this to from binary to unsigned decimal so I can actually read it. And so what I've done is I set this to high. That's why it helps to know what you're doing. And you can see it immediately loads. So if I have a high on load, it's going to load. So we need to pay attention to that. But if you look at the button is always high unless I push it. So this needs to be it needs to be active on low. So the question now becomes, how do I get that to happen? So I can't do anything functionally with the inputs and outputs. But what I can do is I can make a signal and bounce it around. So up here, we're going to type in signal. And we definitely want it to be a load signal. And it's going to be a standard logic. All right, so I just created a signal for my load. Well, what do I want it to do? Well, what I want it to do is instead of this right here, where it says load, I want that to be my load signal. And then what I want it to do is when I have load signal, I want to assign load signal the opposite of what my actual load pin is. So instead of typing that would assign whatever's in load to load signal. Well, just type in not. And that will reverse the load signal and then put that into load. All right. So let's look at that vector waveform file again. Let's see. Run it again. Okay. So if clear is low, so let me go ahead and put load low. Load goes low. I'm going to put clear high. Oh, it's got a 0. Well, that's not good. So if I set it to low, you can see it counts. So clear also needs to be low, which if we look at the data sheet, the default is 0. So we want that to be 0. If both ASET and clear. All right, so we need to do the same thing with that one. Let's see, where is it? That right there. All right, I like that. And it was this one right here. Go ahead and compile it. All right. So now, if I have these two high, I have it to count. Now, if I set it to high, they count. All right, so clock enable high, count enable high, clear high, load high, and it counts. That's promising. So let's go ahead and put this bad boy in. So block diagram file, we're going to set to the top entity, create a symbol. All right. And we'll just go ahead and attach it there. Get some inputs going here. Let's see. Let's get some outputs going. All right. We're going to drop that down here for a minute. I'll explain what I'm doing with this in a minute. All right. Instances are good. I got my clock. Let's go ahead and do some renaming. We're going to call those LEDs because I'm just going to take them to the LEDs. Now this one I'm going to call LED 9 to 7, 9 to 8. And what I'm doing here is I'm just setting this up so that when I'm actually on the board, I don't get the little faint trace light that you normally see. And if I go back to the tool, to the manual, you'll see that these ground out. So I just want to put in a ground. So others, primitives, others. You see it says ground. This is definitely not necessary, but as people have had questions about this in the past, I figured I'd cover it. All right. Get that compiled. Oh, what is it? It's double instance named. You can see here, it's named instance, and I've got one already. So just call it 2. Go to the pin planner, and it's time to actually name pins. All right, so I'm going to load this up. And you can see that it's currently counting through. And if I hit load, I have to, and this is the thing, it's a synchronous count. So I have to wait for it to actually clock through. If I hit clear, it's asynchronous, it doesn't care, but I need to wait for the clock to actually clock through. And that's an example of the LPM counter.